Okay, so we're doing energy efficiency in year 8, so the first time ever, and it's done not a bad job. I tried to get AI to think up something simple for me, and so it's come up with just pulling something up a ramp. It's not too bad because it's hard to do something in year 8, so we do have to add one extra formula. So the amount of energy, the potential energy is mass times gravity, which we'll use as 10 times the height. So I'll give that to you. And you just have to pull up a ramp, you just have to pull up a 5 kilogram mass and see what the force meter says on that. And see if that equals the mgh, which we'll give to you. All right, so the mgh it's it's half kilogram times 10, so that's 5 newtons, and that's the height. So the yep, so that's that there. So that's 0.735 joules. And so that's the amount of energy that you will obtain. So we're going to get that half a kilogram mass to a 15 centimeter height. So that's what we're obtaining, 0.735 of useful energy. But the amount of work, this is your job. You're just to pull it up the ramp, the 1 meter ramp. And what I got was it took me 1.2 newtons, so that was a fair amount of effort. And so that's the total input energy, 1.2. So if you just divide, this is what you're learning, energy efficiency. So you just divide one by the other, and it was only 61% efficient, 39% was lost as heat and sound. So well done, AI. That was a nice, simple one. Hard to think of something simple at this stage without incorporating too much extra physics equations. Just one little extra one there.